So in the first question, a student obtained pure dry sample of sand and sodium chloride from a mixture of sand and sodium chloride. The student uses the apparatus shown. The method consists of 6 steps A, B, C, D, E, and F, which are shown in wrong order. So first one, order the steps in method. So first one, A is there. We have a mixture of sand and salt. What should be the second step? The second step, what we should do, we should make a solution. So we should add water and stir. Then after adding water and stir, what should be the next step? So after adding water and stir, what we should do, we should filter. The reason why we filter, so that the insoluble impurity, which is sand here, will left on the filter paper. Then after after filtration, we can rinse the sand with water. Why we rinse the sand with water? What could be the reason? There after F, two possibilities are there. Like what we can do, we can rinse the sand with water so that all of the, like if any trace of a salt is left, it will passes through the filter paper, and then we can use evaporation, and at the last, or it can be BDE. This is one possibility. Or what else we can do? It can, like BDE is there, one possibility, or it can be BED. That's another possibility, or it can be DBE. These are the possibilities. All will give the same result. So any order is acceptable. It can be BDE, it can be BED, or it can be DBE. But the first one, how DBE, what you have here, you can evaporate. So first one is D. And the second step, what was left on the filter paper, you wash that and leave it to dry. So all possibilities are there. Complete the box to name the apparatus. What we call this apparatus, a piece of apparatus. So evaporating dish or evaporating basin. The next part, why is sand rinsed with water in B? Why we rinse the sand with water in B? What was the purpose? Basically, when we wash the sand, yeah, it will clear any remains of sodium chloride, or it will wash out or dissolve, or it will remove the salt. So to ensure that no NaCl is present or removed, or to clear the remains of NaCl, or to remove the rest of sodium chloride, we wash it with water. Name the process F. What we call this process F? That's filtration. How could the purity of a sodium chloride obtained be checked? It's a solid. How we check the purification of a solid, like whether a solid is pure or impure? The technique which is used to find, so we can check the melting point or boiling point, but for solid, it's melting point. For liquid, it will be a boiling point. By checking the melting point, and it will melt at a fixed temperature. If it is impure solid, then it will melt at a range of temperature. The second question, a student investigated the rate of reaction between dilute nitric acid and a lumps of magnesium carbonate. So when magnesium carbonate react with nitric acid, give magnesium nitrate salt, and water is there and carbon dioxide. So the carbon dioxide gas will escape. The purpose of the cotton wool, it will not allow the mixture to escape from the conical flask, otherwise there will be a greater change in mass. So lumps of magnesium carbonate were added to a conical flask. 40 cm cube of dilute nitric was added, was then poured into a conical flask using a measuring cylinder. Magnesium carbonate was in excess, like more than enough. A conical flask is placed on the balance. The cotton wool was placed on the top of the conical flask. The mass of the conical flask and its content was measured, and the timer was started. The mass of the conical flask and its contents were measured every minute for 7 minutes. So every minute we measure the mass, and we repeat this for 7 minutes. So I want everyone to use the screen annotation and complete the table. The first one is mass of conical flask and its content and total mass loss. You can use the other space as well. It's the total mass loss. The total mass loss means the difference. And the first value, it's not 85, it is at 86 mark. So it's 0, then 1, 1.6, 2, 2, then 2.1, then 2.1. So there's the overall change in the mass, the difference. So here the mass remains same. There's no change in the mass. It means that the reaction stopped. Plot the results on a grid and draw a smooth line graph. So in the beginning, this is the time for 7 minutes. That's the time interval is there. You have the values. The first minute, 0 minute, there was no mass loss. Then that was 1. So when we sketch Yeah, what are the points? You can mark the points. Just mark the points. 2.1. It's okay, 2 and 2.1. Two boxes equal to zero point 0.1. This is 2.1. So when you sketch, so 0, 1, 1.6, the values are 0, 1, 1.6, 2, 2.1, 2.1, and so 0, 1, 1.6. So these points will be in this manner, not this one, because at 2, at 1 it is 1. When you check this value, the mass 86 was there. No, after 1 it is 85. So after 1 minute, the loss in mass is 1. So you have to draw a smooth line graph. Basically, it will come out like this. This is a sketch. Then the average rate of a reaction can be calculated using the equation shown. Average rate is equals to total loss in mass divided by time taken. Calculate the average rate for 30 seconds. So how you'll calculate the average rate for 30 seconds? So on your graph, because 30 second means half minute, so at 0.5 you will draw a line at 0.5 and find how much or what is the change in the mass or loss in mass. Example, if it is 0.51, so 0.51 is a loss in mass and time is in second is 30. So 0.51 divided by 30. What's the answer for 0.51 divided by 30? 0.017 gram per second. The next part, experiment is repeated using an excess of magnesium carbonate. All other condition kept same. Sketch on the grid the graph you expect. So, but what we did, we use a powdered magnesium carbonate. In the beginning, we were using excess of magnesium carbonate, but it was lumps. So the lumps of magnesium carbonate were used. That was in excess. So powder will have a large surface area. So steeper slope. If this is your original graph, if this was the original graph which you plot, then it should be a steeper, faster rate. But the final amount, the final volume should be same because you are changing the excess reagent. If it a limiting reagent is changed, then the rate as well as the final amount of a product will also change. In E1, why does the mass of conical flask and its content decrease? What is the reason why the mass of the conical flask and its content decreases? Because the gas is given off or the carbon dioxide is given off. That's why the mass is decreasing. The gas which is produced here is escape. That is the reason why the mass is decreasing. Suggest the purpose of the cotton wool. Why we use this cotton wool? Not letting the content to escape, because what otherwise what happens then it practically it will not be correct if the Mixture will escape. We only want to prevent the content from escaping. That's right. We only want the gas to escape, but the content will not escape. That's why we put, otherwise, even for example, if you want a gas to escape, so without placing a cotton wool, this can be done. But why? What is the purpose of the cotton wool? So it will not let the content to escape. Why does the graph level off explain your answer? What is the reason why the graph level off? Yeah, the limiting reagent used up. And what is the limiting reagent here? Acid is a limiting reagent, so you should mention the acid used up. That's why no more reaction. If you write reactant used up, then you will not get the mark. Acid used up or no more limiting reagent. So reaction stop. Give one advantage and one disadvantage of using a burette instead of a measuring cylinder. Advantage, it is accurate, more accurate, and disadvantage, it is take time. The next question, two solid G and H were analyzed and tests were done on each solid. Test on solid G, sum of test and observation are shown. Test on solid G, a flame test is done and it give a lilac color. So what this indicate? Which ion is present? A flame test of lilac color. It means a potassium ion is there. A solid G was dissolved in water, dilute hydrochloric acid, and a solution is warmed. A gas was tested with acidified potassium manganate 7. Changes from purple to colorless. So this is a test for sulfite ion. The gas given off is sulfur dioxide, and the ion which is present is a sulfite ion. So name the gas produced in test 2. The gas produced is sulfur dioxide, and the ion present is sulfite. So the gas is SO2 and the compound is potassium sulfite. Because sulfate, if it was sulfate, then barium nitrate or barium chloride will be the test. If you write sulfide, sulfide means sulfur. It should be IT. The next question, test on solid H. Solid H is a calcium nitrate. So they give you the identity that it contain a calcium ion and it also contain a nitrate ion. Solid H was dissolved in a distilled water. The test tube was shaken and dissolved. The solution was divided into 4 portions in 4 test tubes. Drops of sodium hydroxide were added to first portion. We have a calcium ion and we add sodium hydroxide. What is the observation? The first one, it will form a white PPT. And when we add an excess, more than enough more than enough sodium hydroxide, precipitate does not dissolve or precipitate remain insoluble or no change. No visible change. Dilute nitric acid and silver nitrate, so that is a test for halide ion. What will be the observation? What is the observation when we add nitric acid? So there will be no change. And this part, excess of aqueous ammonia is added, and there is a calcium ion. No visible change, no reaction. Aluminium foil and aqueous sodium hydroxide. This is a test for nitrate ion. Were added to a fourth portion. The mixture was warmed. A gas is produced. This gives the ammonia gas. So what is the observation when ammonia gas is given off? So if ammonia gas is there, what we will observe? We'll observe a pungent gas which will turn red litmus blue. The last question, propanol and ethyl ethanoate are both solvent which can be used to remove paint. So we can remove the paint by using either propanol or ethyl ethanoate. Plan an investigation to determine which of these two solvent is better to use to remove the paint. You're provided with a glass slide. You have two solvent and a common lab apparatus. So how we plan this, there are different ways to plan. The purpose of the slide so that you will apply a paint on the slides and try to remove the paint from the slide. So what we will do first, we'll paint the slides. Propanol means it's called a ketone. In A levels you will learn about this. It's called a ketone, aldehyde and ketones. Maybe in biology you have studied something about aldehyde or ketones. But propanol is a ketone group, functional group. So we will apply same amount of paint or same thickness of the paint. Then we will leave it to dry because the wet paint is can be easily removed. So we will leave it to dry. Then we will add drops of propanol until the paint is removed. Then we'll count the number of the drops. Yes, use pipette to or use for adding. I will mention the apparatus. When we add something like we want to add drops, so we should use a dropper or a teat pipette. Then we will repeat the procedure. And then compare the number of the drops used for each solvent. The solvent which remove the paint with least number of drops is better paint remover. Is it clear, this experiment? Another way is there, yeah, you can work out according to that. If add equal, what you can do, you can add equal amount of paint and leave it to dry, then add equal amount of the solvent, and then for a same time interval remove them after same time interval and re-weight again. The one which remove the greater mass of a paint, that is a better solvent.